associated with mobile application development. But hopefully, at the end of this session, you will have a much clearer idea about the topic, and hopefully we are able to convince you on sort of trying out the unidirectional data flow pattern. Let's move on to the today's agenda real quickly. First of all, we'll do a quick introduction to ourselves, and then we will look at what are the challenges in developing enterprise mobile applications. So we will go through a few topics and see what are the key challenges that we face when we try to develop enterprise-grade mobile applications. And then we will talk about the predominant traditional patterns that are used to that we use to do mobile application developments, things like MVC or MVVM. So basically the MVX patterns as we know them. And then we'll do a quick introduction to UDF architecture. We'll get to know the basic characteristics, the attributes of the UDF architecture. By the way, UDF means Unidirectional Data Flow. So we will get to know the basic building blocks of that architecture, and then we'll move on to a discussion on what are the key advantages of using unidirectional data flow architecture in mobile application development. And we will also share some of our experience in using this architecture in real application development, and what are the key advantages that we see in day to day compared to using the MVC or MVVM pattern to develop mobile apps. And then, so basically nothing is perfect. So there are things that we need to take care, or things to watch out when we use UDF pattern. So we will have a quick discussion around that topic as well. And then we will move to share some of the things, if you're interested, where to go from there. And there are a few things that we will share with you, some of the stuff that we have done, some links to the open source projects, and further links to some further studies of the topic. Okay, so without delaying anymore, so basically I have Bishan with me here today. So Bishan, can you give a quick intro to yourself?
Yeah, hi guys. So I am Bishan Madhagudas. I am working as a senior software engineer in i9X Technology. So I've been in the industry for quite some time. I think maybe around 6 plus years, and I'm more focused into mobile technologies, even though I worked on web technologies on my earlier days. Then I moved with doing projects for startups and stuff, and then lately I've involved within those enterprise grade applications. So that's a brief about me. So Suren.
Yeah, excellent. So, by the way, my name is Suren Rodrigo. So, I work as a senior consultant for software product engineering at i9X Technology. I've been in the industry for quite a while, actually more than 14 years now, and my key interests are to sort of use different technologies to bring the maximum value to the customers, like using technologies to develop different solutions so that the customer can get the maximum value out of them. And also I love to experiment with different technologies, and I think especially combining different technologies together in different areas. For instance, the UDF pattern is actually is not new in the web arena. So web developers have been using this for many years now. But what we try to do is to bring that into the mobile space and try to sort of see what we can do with it. And I think we sort of came up with something really good. So today we are going to look into that more. So that's basically about me. And then we will look at the first topic, basically to understand why we need a different pattern or different architecture. It's important to sort of know what are the challenges that we face in developing enterprise grade mobile applications. So these are not by any means, this is not an exhaustive list, so this is not the entire set of challenges that we face in developing mobile applications, but of course these are the things that we find as key challenges when we deal with day-to-day customers who are keen on getting their product out to the market. So the first one, the time to market, or as we call TTM, it's a very important important challenge, because the competition between customers to bring their products into market, especially in the mobile space, is intense. Because mobile space, everyone want to sort of exploit the mobile space and sort of bring their product or convert their traditional products into mobile, and then gather the customers around that.
It's kind of a trend right now.
Exactly, it's the sort of the thing now.
Yeah.
So in that context, so the time to market is a huge problem that we face as developers, because our architectures should sort of support these time to markets that are demanded by the customers. So our architectures, our methodologies have to evolve in a way where these demands can be met. The second one is something very obvious: the high quality of the product that we do. So I think it's if not the most important one, it's one of the most important factors, success factors in fact, in putting a product into the market these days, especially when it comes to mobile. I mean, there are thousands of products. So any product that you think about, you can find a product is already there in the market. So the differentiator lies in one of the key differentiators is about how good the quality is. But the challenge here is that with the lesser time to market, how do you deliver a high quality product into the market? So that is the key challenge as developers that we face. So again, the methodologies, the development methodologies, the architectures that we use should sort of support this type of high quality delivery in a very less time. So they should support automation tools like test automation tools and sort of ways that makes the developers easy to do testing. So that is something that we need to sort of have keen
Actually,
idea
one thing
about.
I noticed in that aspect, what people do is, since they have a lesser time to market, they come up with developing an MVP. But that MVP, they don't care about these or test automations or anything. So there's no quality in that. So when they going to develop it for the version 1, they ends up within a very bad code.
And they usually throw it out. And then they have to start from the beginning. So speaking about MVPs, I think Bishan was right on the spot where the ability to do rapid prototyping, right? So because anyway, customers these days, they don't really understand. I mean, they don't spend a lot of time, gathering requirements for 6 months and then coming up with a product. So what they want to do is bringing the product to market as soon as possible with a minimal viable product or an MVP, as Bishan mentioned, and then sort of get the users to test it and then do pivoting or change the product according to what's the customers are demanding from them. So in that context, it's really important to sort of quickly prototype stuff and then put them into the marketplace and get some feedback and then learn from them and then adapt the product. So in this context, our architectures or our methodologies has to support this process, right? So this is all based on the lean startup model where this quick rapid cycle of you put a product out, you learn from that, and then you pivot, or you learn from the customers, then you pivot according to the demand from the customer. This cycle has to be supported by the architectures and methodologies that we do, and it's a vital thing in the process.
This is where that UI UX complexities comes in.
Exactly.
Like they change all the time when you do the prototype.
Yes, absolutely. So we have to make sure that we separate these concerns as much as possible. So if we separate these concerns, then we have the ability to sort of work on them differently and then optimize them at different levels as well, right? So that is the key here. And then the other fact is enabling multiple packaging and selling strategies. So that's another trend that we see these days, that the customers, they actually don't sell only their product. They sell the product in different ways. For instance, so you might have a mobile application which you are selling in the marketplace, but then you also want to sell different features individually as libraries in this application. So in that context, let's say one of your customers already have a product, have a mobile app, but they just need one of the features in your mobile app. So how do you cater to that customer? So that's a new way of, that's a new market that we usually don't tap into. So the way is that you create them as libraries, and then you can sell these features as libraries. And while you sell these features as libraries, you use the same library to create your app as well. So if you're buying the whole thing, you get the same library working in the mobile app. Or if your customer already have a product, they can just purchase the library and then utilize that. And another aspect is selling the API endpoints. I mean, you can actually get your customers to subscribe into your API, the REST API which you use for the same product which you sell. So these are different ways that we see that how customers are actually marketing their product these days.
Those actually I should have mentioned, like these problems come, these things comes when you do the enterprise grade application.
Yeah, exactly.
Because
Exactly.
for just if you're serving just for the end client, it won't be there.
Yeah, that's something I think we will discuss at the later stage of this as well. Like this UDF pattern is not something that that is there to replace MVC pattern, right? Because MVC will always, or MVX patterns as we call them, like MVC or MVVM or MVP, these patterns will always have their place. But what we are talking about is enterprise grade application development, where we develop for thousands or millions of customers, and then the teams are dislocated around the world, right? And then we have different challenges, these different types of selling opportunities are there, and then you have to quickly pivot between different ideas. So these set of challenges are very common in the enterprise scale. So we have to sort of, when we select the architecture, that's one of the first things that we need to do, is to figure out what is the context we are working on, and what are the quality attributes that we want, and then sort of go ahead with the proper architecture. So the challenges that we are discussing here, as the topic suggests, is basically the enterprise application development domain. Yes. And the next one is another something very obvious, is the ability to develop and deploy features independently, right? So again, when you have different features, so feature complexity is also something that we have to consider here. So these features, some of these mobile features in any application are so complex that you need entire teams actually developing those. So then you will have a feature team. It's now common to have different feature teams, and then have an integration team on top of those feature teams, where they will actually integrate these features and spit out different applications based on the customer needs. So that's another pattern that we see, or a strategy that we see in application development these days. So these type of things has to be supported actually. So in that context, you might actually have dislocated teams working on different continents in the world because of the cost effectiveness of using different teams in different areas in the world. But then they should have the ability to develop these features independent of each other. So if they are dependent on each other and they have to sort of rely on other people to do their work, it's not going to be a sustainable working mechanism or an architecture. So the challenge again as developers is to find the methodology or the architecture that supports this type of working patterns, right? And then we'll look at those things closely as well. And then delivering value continuously. So here, this is another thing that we see, is that customers actually, the value for the customer doesn't come directly from delivering the feature itself, right? So customers don't expect us to just deliver the feature, right? They spec a feature and they tell us to develop that feature. So about 5-10 years back, that's the expectation from the development team. So they have a spec, we develop the spec, and then we deliver that, and then that's the end of story. But today it has changed. So the customers want developers to actually think about what are the future implications of this feature, and how do we utilize latest technology to deliver a better feature than their competitor, and then keep an eye on the future development as well, suggest different ideas, try out different ideas. So a lot of research has to be done within the team, to sort of come up with different solutions that meets the customer expectation. So our architecture should actually have some kind of a mechanism that enable developers to do this. One of the key things that I see is, if you're following the standard development methodologies or standard patterns, you actually don't have a lot of time to do this because you are sort of bogged down with a lot of tasks and a lot of day-to-day tasks. But if you have a repeatable development pattern within your team, like feature implementation complexity is roughly the same regardless of what is the feature we are developing, then that type of architecture will sort of free the developers to sort of think about what are the future implications of this feature and sort of think like the customer and come up with different ideas, and they can rapidly prototype their ideas and show to their customers. So these type of things are going to be really important at the enterprise level. And then last but not least, I want to discuss about cost effectiveness, right? So you need to understand when we say cost effectiveness, this is not only cost reduction, right? So cost reduction is not cost effectiveness. It's just part of the equation of cost effectiveness. Cost effectiveness is all about creating a repeatable saving. Like, can you actually save money in a consistent manner? And can you figure out what is the correct investment that you have to do, the place that where you need to invest the money properly so that you get the maximum ROI for your investment. So these type of decisions also now falls into the development team, because customers, they have a business idea, right? So they want to bring the best business solution that they need to their customers. So as developers, they rely on us to figure out how do we spend the money in the most effective manner. And again, it's not just reduction, it's about continuously sort of doing the right investment so that the maximum ROI can be taken back to the customer. So we think that UDF architecture sort of enables these type of or helps us to overcome these type of challenges. But before we dig more into to understand what exactly the UDF architecture and what are the building blocks there, perhaps we need to take a closer look at the MVC and MVVM patterns. So as we say, the MVX patterns, to get an understanding about what is the traditional approach of application development. So Bishan, maybe you can walk us through a bit about the MVC and MVVM patterns, which are, I think, the most the most common patterns,
yeah,
that we use to develop applications.
Even I saw like huge companies just use those and go ahead with it.
Yeah.
So there's no good it's not a bad practice or anything, but there are some issues we find out, like when you're going to use those in an enterprise grade.
Yeah.
There are certain issues. So those are the issues actually we found when we try to use those things. And one is like application data is in individual views or controllers. So if you're Android guy, you can have your logic in your fragments or activities, and iOS there are view controllers. So you can have data inside your controllers as a local data, or you can just fetch it out and keep it there. So those kind of things can't be happen in enterprise grade applications. So this is a concern for us. And also data is the next big problem I saw was data can pass through views. So you can pass data from intents, or you can pass from seeks if you're using iOS. So likewise, passing data through two views is not a good practice, because views are just views. They should be views, not
the responsibility of handling data. I think the key here is that data, the application data has a lot of value in a mobile app, or in any app for that matter. So what we are doing with MVC is kind of, even if we use MVVM, where we have view models to sort of take care of the data aspect, and then we inject the view model into a view and then read the data from there, is that we have several view models, so many view models. If the application, so the number of view models, or the number of structures we have within the views to hold data sort of increase as the application complexity increase. So there's no one place or one sort of governing body to take care of the application data. So that is one of the key problems I think we have here.
And I think you guys can remember we mentioned that UI UX, like tightly coupled UI UX is a problem for enterprise application. Like if you couple your business logic and data with views, that will be a problem. So these two things is just about that. Like we don't want to depend on views to pass the data or like keep the data. So we just want to get rid of this. So the next one is application data is data can be mutated at any level. So that's very dangerous if you concern about in enterprise application because mutation shouldn't be allowed within all the places. That's very someone can say it's very flexible, but that also this flexibility can also comes very troublesome when you use these things. So in enterprise grade applications, we avoiding these things. So there can be one place where you can just point out, okay, if there's issue with data, here we going to see the issue. So there are places responsible for this.
So the main issue is that yes, as you said, Bishan, there is flexibility in this, but with the flexibility, there's added complexity also, because then anybody can sort of choose to modify data anywhere, right? So if they choose, they can just modify the data. They can just do a simple, backend call in the view itself if they are doing it really badly, for that matter. But they are still allowed to do that, right? And then just update the data then and there. So these type of things. So there's no governing structure sort of to say how the data should be mutated or how the application data should be changed. So this adds a lot of complexity as the application grows. Again, we should say that these complexities, you might not see these complexities at all if you're just developing a simple mobile app, right?
Yeah.
For any app for that matter. But when you are dealing with hundreds of features and many users, and then things can sort of the complexity can sort of increase at a very short period of time, and different developers have their own way of doing things as well.
Yeah.
So that is also a challenge. So they tend
and
to
also because of that code reviewings and all those can be really complex.
Really complex because you do it in a different way, because you have sort of found your own way of doing it,
and also I might have my own opinion to clarify how I did it.
So that is the problem that we see here with data. So there is no proper way of actually mutating that as well. Yes.
Yeah. So the next thing, this is actually a huge one. If you're using MVC, I even did that in my earlier stages in my career. I dispatch the calls from a view and take back the data models right into the view controller. So dispatching and handling all the data models right in the view controllers is really bad. So there's the flexibility to do that in MVC or MVVM. So we want to avoid those little things. So that's a one major point. And also loose governing structure, as we said, allow developers to do whatever they want. Someone can have his own opinion, which might be not wrong or even right. So, but we can't take that risk. We need proper way of doing things. So nobody can do it in many other ways. So simplicity.
Exactly, that's the key word here. I think in an enterprise grade architecture, one of the key features should be that it should be very simple, right? So there should be less moving parts, as we say. So then you don't have to worry too much about how things work, because it's a very simple architecture. The base architecture should be extremely simple. So while MVX patterns sort of have all this flexibility, the problem is that it can be you can add a lot of moving parts if you really want to, right? So that's what we meant by having a loose governing structure when it comes to the application. So different people are allowed to do different things, but then that means you have so many ways the application can get affected. Especially this is there when it comes to events as well. So where do we, as you said, where do we fire an event, and how do you actually expect that event to affect other applications? How do you communicate between different views? So all these things are not actually governed by MVC.
Yeah, as example, if as Suren said, when you do it in many ways, you might end up within searching a way to communicate between view controllers. So you might end with very bad practices like local notifications to notify other view controllers, kind of things. So those are you can avoid those things, but what was the cause for this is the flexibility you had.
Yeah.
So you now is in this bad position. So and also you might find it really hard to document those things as well,
exactly.
because
I think just to add to what you said, Vishan, actually, like if you say, like, take the example of local notification, I don't think it's necessarily a bad practice.
Yeah.
But the problem is if you have many ways of doing it, right? So you have local notifications, and then you use some other event-driven mechanism, and you use another tool to communicate between another two views or something like that. So having this flexibility, where that's what we mean by loosely governed structures. So when you have this type of flexibility, people tend to sort of do everything at the same time. So then all this complexity adds into the base architecture of your product.
Yeah.
And then you don't know when you want to do a change. If the original developers have left, and if it's not properly documented, you will see in some areas we have used local notifications, in the other areas we have used something else. So this adds to the complexity.
And also this will be the main reasons to do testing really hard, because you have many ways of doing this. So you can't,
every test it will be different. So it will take a lot of long time to sort of do the test properly, and to even to understand how application works. So there can be cases, actually I have seen in complex enterprise grade applications. So it depends on the team that you work. So one feature they have used a completely different set of technology stack, like how they communicate, how they work is totally different from the another feature. So this becomes really difficult for one guy who's working on feature A to go into feature B and do a change.
Yeah.
But that is what we have mentioned earlier when we discussed challenges, the time to market, delivering a high quality product with the lesser time to market we have. So that type of things are going to make our lives really difficult if we don't have these structures properly in place.
So those are the main things. There are many other things as well, but those are like the main things which we saw as issues, like slight concerns of us in MVC and like MVX patterns, MVC, MVVM, MVP kind of thing. So next is let's give you an introduction.
So before we move into the advantages of how we are going to overcome these difficulties with UDF, let's take a closer look at UDF pattern itself, right? Because I think it's important to sort of know what are the building blocks of UDF. UDF or Uni Directional Data Flow architecture. So as I mentioned in the topic, there are a few, these are big new words. So if you are coming from a Redux background, or if you have done application state-based development using Redux, and or NGRX for Angular, Redux for React, or anything of sort, Flux or something like that, then this should be like second nature to you, right? So what we have done here is that we have sort of taken those concepts and try to apply into the mobile space, as I mentioned earlier. So just for the people who are maybe new to this area of application state management, I will just go through a few keywords where we used to describe the architecture, and then we will take a closer look at how all these things works together using the diagram that is there. So the first thing is the application state, or the store as we call it. So the store itself can contain different states, but for the simplicity we will take this as the application state. So it is a data structure that store all the application data. So we call it the single source of truth for the application. So it has only one data structure. So none of the views, none of the other elements in your application will contain any data. All the application relevant data will be in the application state, right? In the data structure that we have chosen. And then there are views, right? So views are just UI elements in your application that are used to visualize the current state of the application using the app state, right? So views are automatically notified when the app state is changing. So if you look at the diagram here, you can see that from the application state, a notification comes into the view layer. right? So as soon as the application state is updated, the frameworks will ensure that it will automatically notify the view layer so the views can update themselves automatically. And then there are actions. So actions are actually dispatched, as you see in the diagram, actions are dispatched from the views to request a state change. So whenever a view wants to do a change in the application state, it has to dispatch an action and say, okay, I want to perform this action. Like, let's say we have a form to log in, and then you have a simple view like a username and a password text boxes, and then there's a submit button or login button. So as soon as you press the login button, the login view will dispatch an action saying login with the data that is necessary to do that, perform that action or to change the state, right? That is username and the password. And then some actions actually require you to connect to the backend or third party service to perform the action. So these type of things we call side effects. So if an action requires to sort of connect to a third party service, we call that a side effect. So that's what a side effect is, as you can read from the slide that is here. And then the middleware is where the side effects are managed, right? So if an action, thing like, for example, login. So if you need to log in, definitely you will need to communicate with your authentication service or your backend API. So then that request will be captured, or that action will be captured by the middleware, which are actually interceptors that are used to handle the side effect, and then it will communicate with the backend. And then once the side effect is handled, that is, once the login process is done, it will dispatch another action as saying, okay, login is complete, or login complete action, or something like that, right? So then the unidirectional flow can always resume. And then we have reducers. So reducers are just pure functions that actually reads an action and then update the application state based on the action, right? So again, this is a very quick, I would say 2-3 minute introduction to the whole thing. But if you need more information, you can just Google Redux and see how it works. So Redux has a very nice tutorial in explaining all this, how all these things fall in together, and the whole unidirectional flow architecture. By the way, why we call it unidirectional flow? So uni is one. That means we call it one directional flow is because how the data flows. For example, look at these arrows, right? So if you can see in the image, if you look at these arrows, I'm not sure whether they can see the cursor there.
I don't think they can see the cursor.
Okay, so if you look at the arrows, all the arrows are pointing at one direction. So from the view layer, we have a dispatch coming out of the view layer, and in the action we have from the action we have another arrow going to the right to the reducer, and from reducer back to the app state, and from app state back to the view layer. So that actually completes one cycle. The data flows only one side, to the right hand side, if you have noticed in the picture. And even if you have a side effect, you can see that it is intercepted by a middleware, and then another dispatch happens back to the action, and then it is taken over by the reducer again. So that is why we call it a unidirectional flow pattern, right? So that's basically how the unidirectional flow sort of works. Again, as I mentioned, this is a very quick intro. You can read more about this by googling and getting more information about it. So Bishan, shall we talk about what are the key advantages we have got from using this, and then maybe share your experience as well along the way in actually applying this architecture to our development practices?
Yeah. So guys, there are many advantages. I have summarized some of them here. So first thing is tame the application data and events. So actually this is about single source of truth. So what we discussed in MVC and MVVM, MVP patterns was there are data everywhere, like even in your view controllers, even like you sending them from a view controller to another. Those concerns, there are data everywhere. So at any given time, if you do a debugging, you can't see what's inside your application, because it might be in so many places. So in UDF we have one state, so it has all the data. You have to do anything in your application at any given
Yeah,
time.
exactly. So we have a single source of truth where all the application data is there. So whenever you do an update, you can ensure that that place is the only place that gets updated, and then that is visible to all the views that are subscribed to that state. So then all these views will be immediately notified if there's a change in that application state, and that is why we mean by taking the application data. And also the event part here is that you if you have noticed our previous description is that the whenever a view needs to get something done, it will dispatch an action, right? So it will just tell I need to get this thing done, like I need the user to be logged in. So events are handled using actions, and then it's really easy to manage. So because there's only a single source of truth, if your view has been subscribed into the app state, any change will be notified to you immediately.
Yeah.
So then we have a very structured mechanism to manage application data and events in your application, unlike in MVX patterns. Yes.
And also, guys, this thing actually encourage to do a good things. As example, imagine you keeping your search results in your state. So you can see in a profiler or a performance, whatever the tool you use to manage your performance of the application, you can see this array has many data. So it is like around 1 MB. So you can think about it, and you can implement something like pagination or something in that. So you just have might be 10 values. Now you just reduce it to a KB of data. So those things encourage you to do a good optimization. So that's one advantage, and also separation of concerns, as we discussed. You have one place which govern like one area of things. So like if you did a dispatch event like to fetch some data, these data putting into that state part, like mutation part, happens only in reducer. So you know where to go to check with where are you handling the data. So even there's like 10 developers who are working on the same application, everybody mutates the data inside reducers. So that kind of a separation of concern is there.
Yes. So everything has a place.
Yeah.
Right. So views are just dumb. Views are just visualize the application state data, and they have no application logic, or they don't handle data. And then we have actions. So set of actions which actually dispatch the performing, or the method that contains the data of how the action should be performed. So everything, as you said, the reducers, all the things have a place where it happens. So then if you are even a new developer, if you understand the concept, and if you know that there's a bug in how the application data is being updated, then I need to check the reducer. Because the reduce is just responsible for updating the data. You don't have to go and check or debug anywhere. You just have to go and find what is the reducer that is responsible for updating this particular state, and then just directly go there, right?
And also even though those are enterprise grade applications, you doesn't have to be expert of coding, because like to do a review, you if you know the way of data flows, okay, there's a violation here.
Absolutely.
Anybody can just take a glance at it and see there's an issue in here.
And that falls into the repeatable patterns as well. So one of the nice things I think we will discuss real quickly in the next section as well is that you get into a repeatable pattern of implementing new features or fixing bugs, because you exactly know everything has a placeholder. There's a place for actions, place for reducers, place for the state, and place for views. So then you exactly know what needs to be done when you are faced with things. And the complexity does not necessarily grow with the size of the feature, because it's all about adding a new action, adding a new reducer, updating the application state, and the flow is just the same, regardless of the complexity of the feature. So that actually frees the developers to really think about the business logic itself, the business value itself, rather than worrying, okay, where do I put the data? How am I going to do a backend call, and where do I do the backend call? So all these things are sort of structured and governed by the architecture itself.
And also I like to mention, like imagine you doing a small POC for something. So you don't have to validate the POC throughout all the platforms. Like you don't have to do it in both iOS and Android. You can just say, oh, Android developer, okay, you do this POC, and if it succeeds, you straight away know this is 100%
doable in the other.
doable. And the best thing is it's the same code.
Yeah,
Like,
absolutely. The structure is the same.
Structure is the same, and even Swift and Kotlin is really like siblings.
Similar,
So like very similar. You can just figure out it's the same. So.
And I think one of the other key facts is about testability, right? So what we found out is that it's really extremely testable, because one of the biggest challenges we have in testing mobile apps is that the UIs are really difficult to test, because there are simulators and all these things has to run for the UI aspect to test. But since our UIs are extremely dumb, we can actually do the test without, the entire application can be tested without even writing a single line of code in the UI layer. Yeah. So what this means is that you can actually test the whole application logic before even you start writing any UI. So that type of separation can be achieved. So what this does is that this will free the developers or the designers to come up with different UIs. They can change it anytime, as long as you are just calling the same actions and same application, you are using the same app state data, then you can simply be creative on the UI layer. Yeah. And that adds a huge advantage, to sort of do rapid prototyping, and pivoting, and all these things can be sort of supported by that.
And the next thing is right level of reusability. So this is also a big advantage, and so what this means is have the ability to add reusability as and when the application is developed, rather than planning it from the beginning. Yes. So that's a main thing. Like we actually don't have to predict what's going to happen, and just we can just when we develop it through, we can just change our things. There won't be huge changes. Like imagine you have changing your data model or somewhere, so you just have to change your data model, and your app state have all the projections. So so you might have like one place or two place to just change it.
Yeah,
there's no huge, because we have decoupled all our UIs and everything. Reusability aspect.
It's one of the key factors, I also think, because the main idea is that some people tend to break the application at a very early stage, which is not good, because then you can't sort of you are, it's like you are breaking the application into 1,000 pieces and then trying to put it back together again. Whereas the proper approach is that you have to refactor the usability, the reusability into the apps, right? So you have to develop the app and then make sure that it's sort of as and when the need comes, you remove items and then bring it back to the, then create reusable components as and when the need arises, rather than assuming or doing premature optimization. Then it will really slow you down. If you do premature optimization, that's one of the key points, that because you think too much, right? You don't know how this is going to turn out, but you still spend a lot of time trying to create a reusable component, whereas this might not be reusable at all. So you might end up not reusing it at all, right? So that is one of the key advantages. So I think we are almost running out of time, so we will really quickly share some of the our real world experience, right? So Bishan, you can.
So obviously we got help from UDF to manage almost all the challenges successfully. So to our surprise, there were another many benefits too. One is like we, as I said, help us write more predictable code across both platforms, like Android, iOS. The code will be in same structure. So if you very careful and use method names and things similar, so you can really create a good code between two platforms. So if one platforms have achieved one function, it will be the same to achieve that in the next platform.
Yeah.
So it's very predictable.
Yeah. So here the question the audience might be having is that we are talking about native application development, right? So but then there are hybrid application development these days, like React Native, right, Vue Native, and all these things are there. But then what we are talking about here is the scenario where our experience is that we are involved with an enterprise grade mobile application where React Native is really not an option because of some of the hardware that we specialized hardware functions that we need in the application, right? So again, and there are many situations like that. And in the enterprise grade, I would say that a lot of things are highly customized to particular industry, particular domain. So in that context, things like React Native might not be matured enough to handle that type of load, and individual optimizations and memory optimization, CPU usage optimization based on the platform, based on the mobile device that you're using, those type of things are really sort of difficult when it comes to these hybrid methodologies. So in that context, what we found is that we can actually achieve the same amount of productivity level, because the biggest advantage in using hybrid is that because then you have to code once and then forget about it, because it will develop the app for iOS and Android and any other platform.
Actually, I have to mention one thing also, like enterprise applications are like running not only in the pretty devices you have,
exactly, rugged devices,
on rugged devices as well. So
in our scenario, that's the case. So we have to support for some rugged devices.
Yeah.
So, in that context, I think what we found out is that even though we have to code separately, like iOS and Android separately, the structure, the code structure, the coding structure, the patterns are identical, right? So when you sort of have that type of repeatability, or you can repeat the same thing in iOS and in Android, it becomes really easy for sort of a guy who's working in Android to go and take a look at the code in iOS, Xcode, and just see, okay, this is what is happening there, because they understand the structure, then it's really easy. So these type of things are really have made us productive in achieving our objectives.
Yeah.
Right.
So the next big thing is actually it gives us the confidence that this is guaranteed. Like as we matured, we turns out like we write the code and we dispatch the event, and it will, if it comes to our on state update methods, if it notifies, that means full circle is complete, because our UDF architecture is really strict on things. So if you do a mistake, it will immediately break and show it like you doing this. So that since we have the confidence, our all the estimations and the time we spend on developing got really reduced.
Yes.
Our estimations are now
estimations actually became much accurate. Plus, we were very confident in trying out new things because we knew the complexity does not grow with the feature itself. We don't have to waste time on deciding how are we going to fire events in this, and what is the data structure for this, anything. We just have to decide what is the application state data structure. And then that's the discussions are. We just discuss this is the application state we need, and then we can just get into the work. Because from the network layer upwards, it's all the similar code, right? It's absolutely the same code, and then we are not firing events here and there. All our views are very well disciplined, and they exactly dispatch just actions, and then they just get the data from the app state, and they are really done. So this sort of helps us to achieve this type of confidence and then concentrate on better stuff, like actually thinking about how the feature will actually be used by the customers.
And also when we estimating, imagine we have a feature to do, like maybe a search feature. So do the functionality of this feature for the Android and iOS exactly the same estimations, because you do the same coding in both. So the only thing will be different is the UI UX implementation. Other than that, the estimation is actually very close.
Absolutely.
Yeah.
Absolutely.
Okay, the next thing is helped us to properly do separations of concerns and organize the code correctly. So that's what we would discuss throughout entire session. So we have separated out, and it's helped us to do a proper documentations and do guidelines to our new developers. So we pretty much confident on our way of go ahead. So it won't change even whatever the requirement is.
Yeah.
So
yeah, I think that's the thing that we discussed earlier as well. Like predictability and estimation accuracy, all these things became really easy to do with this particular architecture. So basically, as we mentioned earlier, this is I think we have discussed this as well. Complete separation of concerns. I think more or less we have gone through this as well. Okay, so basically, UDF has a lot of advantages when it comes to enterprise scale application development, but there are some things to watch out in that context as well. So nothing is perfect, obviously, right? So we have to be careful about these things when we are using the UDF pattern. One of the main things as we started with this is also that we faced is that the pattern itself is a bit difficult to comprehend, because there are some key concepts which you need to get into your system, like what is an action, what is the role of an app state.
And actually this was hard for the native developers.
Yes, exactly.
If you're coming from a React kind of a background,
this is second nature.
Second nature. But when we try to teach this to a native developers,
it's difficult. That is what we found out. So that's why I mentioned, that's why I had that slide also, to give you a very brief idea about the key concepts. But I think you need to sort of really get this into your system. What are these elements like actions, reducers, middleware, side effects, app states, and all these things means, and how they sort of are put together. And and also this type of architecture requires a bit of a boilerplate at the beginning, right? You need to do some boilerplate code at the beginning, but I think we have a solution for that as well. We have created a boilerplate and shared it in GitHub. You'll see the links in the coming slides. And that takes care of a lot of complexity. And then once the boilerplate is done, then it's actually a breeze. A lot of things can be done very, very easily. And all these advantages are just there. You don't have to repeat the boilerplate at any cost. Like everything works regardless of the complexity of the feature, you can still use the same boilerplate without issue.
And we have a pod for the boilerplate, so you can just...
we have pod for iOS and then Android library for Android guys, right? So we will share those links with you. Take a look. Let us know what you guys think about it. And then and one of the key things, I think the most complex thing in the UDF architecture that I have come across is actually managing the application state. The data structure itself, what are we putting in the application state, right? So that is a key consideration, right? So you can't just put everything into your application state, then the state will grow big. And I think Bishan tapped onto it, like having like 1 MB of data kept in your application state, not a good idea, right? Because application state is in memory, right? So you need to understand.
And also the basic concept is, if you're putting something in a state, that should be shared within maybe two controllers.
Exactly, because that's the advantage.
If you don't share those data among other places, better to be a local data other than putting it in a state.
So that's another trap. So I have seen a lot of guys, because as I said, this UDF pattern is nothing new, right? I have used this for years in web development. But in web development, one of the things that, one of the traps is that we try to handle everything with the state. We put everything in the state, and then try to see, okay, let's put everything in the state, and the state gets really, really complex, right? So that's a pitfall that we have to really be careful of, right? We have to see what is the usage of putting this here. Is this being used by someone else? So is this something that we will need at the latter part of the application? So these type of considerations, I think we spend most of the time discussing these things, like how should be our state be? And then there are certain practices. The state is, you don't just do it one time and forget about it. it has to be refactored as you go on, right? As new features come in, sometimes you can share the state variables between two features, which is not a very good idea if these two features are really unrelated. But then there are instances where you can do that, and then you have to, that's one of the key points here, like you have to be really careful of your state and be.
And also when you're writing projections,
Yes.
to access those data in anywhere, those projections, if you do it in a in a like a as you go concept, it
Yeah.
will be a trouble. What you have to do is this, what we learn, like you have to create a PO functions and make it a chain, like first you access
Yeah.
maybe whatever the array in a state from a one function, and next function will access that function and get the
Yeah.
data out of it likewise. So whenever the change happens in a model, it will be one line of a code, so no other functions will get affected
Yeah.
of that.
So I think Vishan wandered into another word, projections. So
Yeah.
we are now going into like bit of a advanced level, but I think we can organize a bit of a coding session as well to show you what we mean by these things, and then it will be much clearer to you. But I think we don't have a lot of time in a session like this to do this. But let us know in the comments if you are interested to know more about this pattern, and then we can sort of see whether we can organize something where we can actually show some of the important things that Bishan discussed. So all these things will make our lives much easy, right, in doing day-to-day development. And real quickly, just to give you a quick idea about where to go from here. So I think I mentioned to you about, if you are new to UDF or Uni Directional Data Flow pattern, go to the Redux main site and just go through their introductory tutorials to understand what the pattern is. And then we have sort of
Boilerplates.
yeah, we have created these libraries where you can actually use, and we also have our boilerplates, which we will let you know the links in the comment section. And these libraries will just help you to get out of the ground, right? So they, as Bishan mentioned earlier, we have 1.4 iOS application and an Android library. So for Android application, and if you see the picture sort of contains all the stuff that we have put in the boilerplate, these libraries. So these libraries takes care of the boilerplate code itself.
Yeah.
Right?
So you don't have to follow our UDF architecture or
No.
anything. So you can make your client maybe MVC if you want.
Absolutely.
But
So
data management part we will
be handled by these things, right? So as I mentioned, if you are interested to know about more about this pattern and sort of be part of the development of this, please let us know in the comments, and we'll be happy to sort of work with you.
Yeah, this is open source.
Yes, it's in the GitHub repos, and we will keep on sort of adding more stuff to this. We are now in the process of actually creating a boilerplate, two boilerplate applications, which we will share the links as I mentioned, so that it will contain the whole thing. Like this is a library which we have shared, but that boilerplate will sort of show you how to sample app as well. It will include a sample app as well for both iOS and Android, where you can just take it and then start from there. That will be really easy to do. Okay, so I guess that's it for today, guys.
Okay.
I'm not sure how we're doing with the time.
Yeah, see you.
Okay, guys, thank you very much. Take care.